Okay, in the previous lesson, we've used trig identities to verify expressions, okay? So right now, what we're going to do today, we're going to solve trig equations and we're going to use identities to make this happen. I want you to consider the following graph. Cosine of x equals 1/2. And in other words, we're trying to find the value of the degree, which is x, when the ratio is 1/2. And if you look at the graph, we know that this is the cosine graph. We know that at 0 degrees, it's 1. And we know that at 2 pi, it's also 1. And then at 180, it's -1. So we want to figure out when will the angle be where the ratio is 1/2. In other words, given a certain angle, the ratio is 1/2. We know it occurs at this point, 1/2 occurs at this point, and 1/2 also occurs at this point. So we know that x equals pi over 3, which is the same thing as saying 60 degrees. So pi over 3 is in radians. Now we have the other answer that occurs as a graph continues. It's continuous. And it's also going to be 1/2 at 300 degrees. Part of my lesson, I did ask a question. When does 1/2 occur on the graph? We know that the period for pi is 2 pi. I mean, for cosine is 2 pi. And we know that it repeats. So that gives you a hint as to, will this answer ever come up again? And it does. And I'm going to go ahead and show you that it occurs also here. It occurs here. It occurs here. It occurs here. So there are many points on the graph that y equals 1/2, or it appears on the graph again. Different points on the graph. So to describe all those possible answers, I'm going to write the answer in degrees, and then I'll write it in radians. So we know that the first time it happens is at 60 degrees, plus we know it occurs every 2 pi. Okay, and k is any integer, positive or negative. Now, the other time that it happens, or the other point in which k is equal to 1/2, is at 300 degrees. And it occurs every 2 pi, so it's 360 degrees times k, because remember, the k indicates that it's going to repeat. Okay. Now, here at the bottom, it does tell us the answer in radians. We know that the answer in radians is going to be, and I'm going to go ahead and write it in blue. It's going to be pi over 3 plus 2 pi k. And the answer is also 5 pi over 3 plus 2 pi k. So the difference between a regular equation and a trig equation, in a trig equation we know that the answer may repeat because of the nature of the graph, of sine, cosine, and tangent. So I'm going to go ahead and solve this example with you here. I know that I have 2 tangent of x minus the square root of 3 equals tangent of x. What you're going to do is you're going to do basic algebra properties here. You're going to subtract tangent of x, subtract tangent of x. And so we have tangent of x minus the square root of 3 equals 0. So I'm going to add square root of 3 to both sides. So you add square root of 3 to both sides, and you get tangent of x equals the square root of 3. And here is my graph. And you notice that I wrote down the square root of 3. Here's the square root of 3. So we know that the tangent of 60, gives you 1.73, which is what we have here. So remember when I was teaching you how do we figure out the angle, we're going to go ahead and find the inverse tangent of both sides, right? So let me erase this here real quick. Let me erase this. So what I'm going to do is I'm going to find the inverse tangent of, in this case, it's square root of 3. Now, if I come over here and I go to my functions, remember here I'm using degrees, so make sure you're in degrees. So inverse tangent, and I'm going to go ahead and write the square root of 3. And you notice you get 60 degrees. So the angle is 60 degrees. Now, if you want it in radians, it's going to be 60 times pi over 180, which in radians, it's going to be pi over 3. Okay, it's going to be pi over 3. Now, since tangent has a period of pi, you know that it's going to repeat. So the answer doesn't just only occur at 60 degrees, but it occurs at every 60 degrees in the cycle. If the cycle is repeated, then all you have to do is add 180 degrees to 60 to figure out when it's going to occur again. So your answer is going to be 60 degrees plus 180 times k. The k allows us to repeat, make it repeat. So right here, if I put 60 plus 180, I should get 240, right? And you notice I get the same ratio again. You see that? And if I want to find the next time it occurs, it's actually going to be 240 plus 180, right? And you see that? And the ratio is still the same. So if you want to describe it in radians, then it's pi over 3 plus 2 pi times k. I'm going to do this guided problem with you. So we have 4 sine of x equals 2 sine of x plus the square root of 2 over plus the square root of 2. So I'm going to go through the process, the algebra process. You're going to subtract 2 sine of x from both sides. So what you have is 2 times the sine of x is equal to the square root of 2. And then what you do next is you divide by 2. So you get sine of x equals square root of 2 over 2. Now the question is, how do I find the angle? Remember I taught you the inverse function. The inverse function is going to give you the value of the angle. So we want to know what angle will give us a ratio of square root of 2 over 2. And I have here the square root of 2 over 2 is 0.707106. So we notice just by looking at this table and also at the graph that it's going to occur in 2 places. It's going to occur at 45 degrees. See how it's 0.707. And it's also going to occur at 135 degrees. So we actually have 45 degrees or 135 degrees. But since it's periodic, we know that the answer is going to be repeated after the period after the period ends, it's going to start again. So how do you describe that? I'm going to go ahead and write it here in degrees. 45 degrees plus the length of that period, which is 360. And that K value tells you that it's going to repeat. In other words, if K is 0, then it's 45 degrees. If K is 1, then it's 360 plus 45. And then the other answer is 135 degrees plus 360 times K. I'm going to go ahead and write the answer in radians also. So in radians, it's going to be pi. I'm going to write it in radians over here on the side. So in radians, it's going to be pi over 4 plus 2 pi times K. And then also it's going to be 3 pi. It's also 3 pi over 4 plus 2 pi K. Since it repeats. Here's the next example. And we're going to go through the process of solving this algebraically. We have 4 sine square root of x plus 1 equals 4. The first step is to subtract 1 from both sides. So now what we have is 4 sine square root of x equals 3. We're going to go ahead and divide by 4. So we have sine square root of x equals 3 over 4. Get the square root of both sides. So we have sine of x equals plus or minus square root of 3 over 2. Okay, so we actually have two sets of answers. So let me, on the side here, I have inverse sine of sine of x is equal to the inverse sine of square root of 3 over 2. And so the question is, when does that occur? Well, I'm going to go to my calculator here. Functions, inverse sine. I'm going to go to my functions, inverse sine. Square root of 3, right? Divided by 2. And it occurs at 60 degrees. Remember that it occurs in 2 places. If you look at the table, we have 60 degrees, it's 0.866, and at 120 it's 0.66, and then it repeats. So it could be at x equals 60 or x equals 120 degrees. So to represent this as a repeating answer, it's going to be 60 degrees plus 360 times k, or 120 degrees plus 360 times k. Now remember, it's also negative. So what I'm going to do is I'm going to find the inverse function, inverse sine, when the ratio is negative. And so I'm going to write negative square root of 3 over 2. And you notice it's also negative 60. So let me give you the other answer. So the other answer was sine, inverse sine of sine of x, inverse sine, and it's negative square root of 3 over 2. And I'm going to go ahead and write it underneath. And you notice that the angle will either be negative 60 degrees or negative 120 degrees. Okay. So you know it's periodic. So the answer is going to be also negative 60 degrees plus 360. Okay. Negative 120 degrees plus 360 K. And that's gonna give you the answers to every possible answer. And if you look at the line above that, it's giving you the answer in radians. So let me highlight it so you know the answer in radians. Okay. So example 3, we have the cosine of x, the sine of x equals 3 cosine of x. And so what we're going to do is we are going to divide both sides by the cosine of x, because we know that that's going to be 1. That's going to be 1. So if I write this down, I have the sine of x equals 3. Okay. So we want to know when will it be, what will be the angle that will give us a ratio of 3. And if you know sine, you know that will never occur because it oscillates between 1 and negative 1. But supposing you still wanted to figure it out with your calculator, what you would do is you would get the inverse of 3 and you would get the inverse of sine of x. So in this case, it would be x is equal to the inverse sine of 3. Now, what this is saying is, can you give me the angle that will give me the ratio of 3? So if I come over to my function, inverse, sorry about that. If I go over here and I go to my function, inverse sine, and I put 3, you're going to notice it's undefined. So what does that tell you? This will be no solution.